Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Today we're at Maple School, home of the Mustangs, and we're here to Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And in studio with us we have Alyssa. And Alyssa, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Alyssa, where do you go to school and what grade are you in?
I go to school at Castle Elementary and I'm in 6th grade.
So 6th grade, you're a Castle Knight, correct?
Yeah.
All right. Have you been a Knight for a long time?
Since 1st grade.
Since 1st grade?
Yeah.
All right. Now, it's my understanding that you're working on decimals and fractions, correct?
Yes.
All right, well, we're going to get to that in a minute, but the reason I wanted you to go through all those phone numbers is because those phone numbers are very important for the next few weeks, because if you phone in and we do one of your math problems on air, you will automatically receive yourself a gift. That is Holiday Lights at COM.
Holiday Lights at COM is back. Drive through this 3 million light extravaganza from the comfort of your car, all brought to you by Dignity Health. Enjoy countless colorful displays for the whole family.
All right, so there you go. You can see the information is up there. We'll leave it up there for a few moments. Every Tuesday and Wednesday through December 8th, if you phone in to do the math and we do one of your math problems, you will receive yourself a pass. Let's leave it at that. I'm not sure exactly how you get the pass, but you will have a pass for you and your family to take an entire vehicle full through the Holiday Lights at COM. And
Now,
if you
they
haven't
said-
done that yet, it
Yeah.
is quite the scene.
Now they said no limos, Mike, so you're gonna have to leave it at home this year.
Yeah, don't I wish I had a limo or a big bus or RV or something. Anyway, so last year they started it where you would drive through instead of going through the actual COM Zoo. And it was a big success, and a lot of people said, hey, you know what, it would be nice if you kept this going the same way. So if you phone in today, tomorrow, in the next couple of weeks, you'll be able to get yourself a, hey, you know what, it did sell out most nights when people were there. So people would show up, and so you will be able to have an advanced pass by calling Do the Math, and then you figure out what day you want to go, and you're as good as there. All right, so there we go, Holiday Lights again. Hey, you know what, it's never ending, the Holiday Lights at COM. All right, Alyssa, are you ready to do a quick little problem with us?
Yeah.
All right, head on over to the board. And you said there are 3 kids in your family.
Yeah.
So, and you're in 6th grade, so I want you to write the fraction 3/6, 3/6.
Okay.
And do me a favor, that is some excellent penmanship you've got, but can you erase that and make it 3 times bigger?
Okay.
Ah, there you go, nicely done.
Good scale.
So 3/6, what you and Devin are going to do is you're going to discuss and talk about and do, you're going to turn that into a decimal. All right, so you and Devin go at it.
So from what I understand, you've been working on this skill set. So tell me how you would start off with this fraction and considering how to convert it to a decimal.
We would make it into a division problem,
Okay, straightforward. So go ahead and how would you set this up?
like this.
So most students that are looking at this are going to be thrown off at first because generally when students first learn this manner of division, they would see a larger number on the inside. But here you have the numerator, the smaller number under the bracket. Go ahead.
Wait, what?
So we're going to start dividing here, you said?
Oh,
To
yeah.
find that we're going to turn 3/6 into a decimal.
Okay, so we do our multiples of 6. First,
So you're rewriting 3 as 3.00, which holds its value, and you're using multiples of 6 to find out how many 6s would go into the first group of 30, if I'm not mistaken. Go ahead. We have our first 3 groups, 6, 2 groups of 6 is 12, 3 groups of 6 is 18, 4 groups of 8 is 24, our 5th group of 6, here we go, that's 30. Okay, so what does that tell us?
that 6 goes into 30 equally 5 times.
Okay. And working through this as a standard division algorithm. Now, if this was 30 divided by 6, 5 would be our solution, but we're not dividing 30 by 6. We're dividing 3.0 by 6. So, as you continue through, that decimal is going to play a role. So you set up 30 minus 30 to see if there would be anything left over to carry into the next part. So 30 minus 30 equals?
0.
Correct. And then since that next place value is 0, we don't have to go any further since we know that 0 divided by 6 is 0. So now we brought in that decimal value after the 3. What do we do with that decimal value now that we're here?
We bring it up.
Go ahead and bring it up. So what does that tell us as far as 3/6 as a decimal value?
It's 0.5.
So the equivalent decimal for 3/6 is 5/10.
And we'll do a little bit more with that in just a little bit, but I know that you've also been comparing fractions and things like that. Nicely done on that first one, and that brings us to today's Math in the News. All right, today's Math in the News has to do with a little something that Alyssa was just working on, and you said that you are comparing fractions in school, correct? All right, so that's going to, in a way, go with what we're doing right here. So on the screen, what do you see?
2 hamburgers.
2 hamburgers. You like hamburgers?
A little.
A little? Oh man, here man, eat me some hamburgers. Let me tell you that right now, especially over at Grillin' Burger. We love Grillin' Burger. Lydia, make up those
This one's the size of
burgers
my head.
over there. There you go.
There we go.
All right, so
All right.
Alyssa, if you had to choose between those burgers, which one would you probably want? The one on the left or upper part of the screen, or the one on the right or lower part?
The one on the right.
This one right here?
Yeah.
Okay. So what makes that one more appealing to you? Why would you like this
It's
one?
the onions, right? Yeah, look at that right there.
Because it's smaller and the bigger one won't really fit in my mouth.
There you go. All
Oh,
right.
you're
So
going
it's
to do
a
this in
smaller
one
one.
bite? Is that your goal? That's amazing.
No.
All right, so now let's go on and take a look at the next slide. Have you ever heard, this happened long before you were born, maybe even before your parents were born, but certainly not your grandparents. Have you ever heard of the Burger Wars?
No.
No, well, this is a big day for you, all right? Burger Wars are still going on today, but there are a lot more people or companies in the Burger Wars. Have you ever heard of McDonald's and Burger King?
Yes.
Those were the first 2 companies, let's say, that started the Burger Wars. All right. So Burger King came out and they said, hey, you know what, we've got better hamburgers than McDonald's. And McDonald's said, well, no, we've got the original burger and we've got better burgers than Burger King. So they have battles all the time over who has the best hamburgers. Have you ever seen commercials like these?
Yeah.
Okay, I mean, they're still out and they've got different products and things like that. But let's get into what you're doing also, all right? We have 1/3 or 1/4. Now, if you had to compare those fractions, would you want a hamburger that is 1/3 of a pound, or would you want a hamburger that is 1/4 of a pound? If you wanted more hamburger. So which one do you think would be more of a hamburger? What, 1/3 of a pound or 1/4 of a pound?
A third.
A third. Why a third?
Because 1/4 is cut into smaller pieces than 1/3.
1/4 is smaller, it's a smaller piece than 1/3, right? Now, this is why you were a very bright 6th grade student, because a lot of people back in the 1980s didn't understand that.
It was a weird
right?
decade.
There was another burger place called A&W, and they said, you know what, we're gonna go after the McDonald's 1/4 pound hamburger. And they said, we're gonna offer a 1/3 pound hamburger. And people were reluctant on it. Why do you think somebody would want a 1/4 instead of a 1/3?
Because maybe they thought that since 4 is bigger than 3, 1/4 is going to be
Ding,
the
ding,
bigger
ding,
one.
you are the big winner today, Alyssa, because that is exactly what most people thought. Even adults thought, well, 1/4, why would I want a 1/3 of a pound burger if I can get a 1/4, because 4 is bigger than 3? But as you stated earlier, a 1/4 is a smaller piece than a 1/3, isn't it? So what A&W did is they withdrew that promotion, and they said, you know what, this isn't working, we're not selling more burgers, people just don't get it, all right? So what they've done is they've come out with a new promotion. So they're calling it a 3/9 pound burger. Does that make sense? You think, I mean, have you ever seen this yet? 3/9 of a burger, pounds burger?
No.
No? All right. Well, this is what they're doing now. Because 3/9 is actually, if you simplified that, do you know how you would take 3/9 and simplify it?
No.
What goes into 3 and 9?
6.
Well, 6 can go into, not evenly 9, but does 3 go into 3 and 9? Can 3 go into 3?
Yes.
How many times?
Once.
Once. And how many times can 3 go into 9?
3 times.
3 times, right? So we get 3, 6, 9. So 3/9 is the same as 1/3, isn't it? Okay? Now, if people see this, do you think they'll want a 3/9 pound burger or a 1/4 pound burger? Which one do you think? Like if I said, I'll give you a 1/4 pound burger or a 3/9 pound burger, which one is going to give you more, do you think?
The 1/4 pound.
Ooh, I would do a 3/4 pound.
A 1/4 pound burger?
Okay, now we're talking solutions that matter. Okay.
Hey, mixing it up, let's go
Yeah,
3/4, all right? So anyway, you see in the background here, they have 3/9 and 1/4,
Yeah.
all right? And you see that symbol right there? Do you know what that symbol means? Have you done that in mathematics yet?
I don't think so.
Greater than? Have you heard of greater than, less than, or equal?
Oh, yeah.
There you go, right? So they're showing you that 3/9 is greater than 1/4, because remember, if we take 3/9 and simplify it, that's 1/3. And you said that 1/3 is bigger than 1/4, isn't it? All right? So the promotion that A&W has right now is they're now going with 3/9 of a burger so that people don't think of it as a 1/3 being smaller, people that don't understand the idea of the fractions. So,
Okay, hear me out. McDonald's, the 4/16 burger. Let's get back into this war. These wars will never end. Play the game. That's
there you
right.
go.
That's right.
They said nay, nay, nay on that 4/16, so
Get
we
there.
can keep going on
You know
these
what I'm
things
talking
all
about.
day. But anyway, that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. And we're going to go to the phones right now. And Nathan. Oh, you know what? I forgot all about that. We are going to be going to our language of mathematics first. All right, we'll be back with that.
All right, welcome back to Language of Mathematics. Mickey here. And today we're going to be talking about digits. And no, it's not the digits you might ask someone, so you can call them or send them a text later. We have different types of digits we might be talking about today. We have two options. You determine which one you think is the mathematical definition. All right, so first, we have digits on the left here. We have this 1, a 5, and a 3, and we're being told these are all digits. They're numbers. They could be the mathematical definition, but let's continue exploring and determine which one we think is the most important or the most useful to us in mathematics normally. We also have a picture of a hand. If you didn't know, all of these fingers and your thumb are called digits. So your first digit, second, third, fourth, and fifth digits. You see here, we have those. So the question is, which one is more important in mathematics? Depending on your age, you might use both. Let's continue looking. So again, we have digits like on a hand. We have a really nice x-ray here. Not my hand, but it's looking pretty good. We have your thumb, your first, second, third, fourth, and fifth digit. Now you may be wondering, Mickey, I use my fingers in math. 1, 2, 3, 4, 5, 6, 7. I use them to count. You're absolutely correct. We do use these digits to count. But in math, we typically identify a digit as a number, okay? Could be any number. Every number out there is a digit. So when we're looking up here at the board, we notice we have the digit 3 and the digit 2. So the digit 3 here, we notice it's in the tens place. Well, but the digit 2 is here, so why is one of these worth more than the other? Even though they're both digits, why is there a difference? So we notice here the digit is a 3, but because it's in the tens place, it has a value of 30, or 3 times 10 for the tens place. We look over at the 2, it's in the ones place. It only has a value of 2 though, because it's in the ones place. So 2 times 1, its value is 2. So even though these are both digits, they mean vastly different amounts or quantities of something. We look over here on the right, and digits come into play in scientific calculations as well. You notice this digit at the front, this 0, well, when you're looking at measurements, this 0 does not play a very significant role. It doesn't have a value really in this problem. We look at the next one also, it doesn't have a value really either. We're saying there's no measurement needed in the tenths place. But now we notice we have a first, second, and third significant digit. The first one is the 5 in the hundredths place. What that means is I can guarantee I have a value of 5 hundredths in my measurement or calculation. Same for 6 in the thousandths place. And you might be wondering, well, we didn't count the zeros at the beginning. Why are we counting the zeros as significant at the end? The nice thing is with this 0 as a digit, it is significant because we are guaranteeing there is no measurement in the 10,000ths place. So when you are doing something scientific and doing that calculation or trying to figure out what an answer is or solution, when you have a 0 at the very end of your calculation, you are guaranteeing that digit is not needed, and you're guaranteeing that that measurement does not go any farther. So it's a way to show a precise measurement or solution. All right, hopefully you learned a little bit about digits, not just the ones on your fingers today, and that is today's language in math.
Always something new with the language of mathematics, words that students take a look at and they think of one thing, but then we can see they have multiple meanings, especially when it comes to the language of mathematics. All right, now we're going to go to the phones. And Nathan, how are you this afternoon?
Good, and yourself?
I'm wonderful. You're working on percent, correct, and interest?
Yeah.
All right, let's hear the math problem that you're working on.
So if you borrow money from a car at 50% interest, how long until your debt doubles if no payments are made?
All right, so the interest rate is 6%, correct?
Yeah.
And that's 6% per year, correct?
It does not say.
Okay, well, let's just go with 6% per year.
Absolutely.
And it said if you borrow money, all right, so it doesn't have a specific amount, does it?
No.
All right, so Devin, why don't you start off with an easy amount, and we'll do 6% every year. And you need to figure out, Nathan, how many years it will take until that debt doubles with no payments, correct?
Yeah.
All right, Devin, take it away.
And the great thing is the fact that they didn't give you a starting value is that you could pick any starting value. So for the sake of our problem, if we're dealing with percents, which we know relate to for every 100, let's just start off with 100. I don't know what kind of car you're going to get for $100. Probably not one that you want to have out on the road. But for the sake of our talk, let's go ahead and start there. So I'm going to go ahead and start by saying I borrow $100. Now, when we talk about interest, this amount grows by a certain percentage every year. And so if we're starting off with 6%, what we're doing is we're adding 6% of this original value. So what we can do is multiply by that percentage factor. Now, there's a lot of different ways to do this. You can multiply it by a fraction that represents 6%, or you can add that. So for the sake of our conversation, one of the things I found is a very helpful tool for adding percentages is to multiply by the decimal equivalent of that. So for example, with 6% as our interest rate, I'm going to go ahead and multiply 100 times 1.06. This is one way that you'll be able to add 6% to an initial value. So I'll go ahead and just start off with the 6's here, 6, and that's going to be 0, and then 0, and then 6 here. We'll do the same thing here to the next place value, which is going to be a 0, so I'm just going to go ahead and throw an X down, and I'll go ahead and throw in the 1 here. So 0, 0, and then 1. I have 2 decimal values, so I'll make sure I add them over a bit, and then add them up. And I have $106. Now, I'm going to take this value. This is the first year.
Now, before
right?
you go on,
Yes.
so Nathan, let's make sure that you understand why he's multiplying by 1.06 instead of 0.06.
Okay.
Do you understand that?
Yes, I do.
Okay, because if you don't, now would be the time to say something. So.
Essentially, we're ending up with 106% of our original value. And that's where the 1.06 comes into play. So after year 1, I'm just going to go ahead and start off with a quick table here to organize our information. After year 1, I'm going to end up with $106 as the debt. Now, we're going to keep doing this until this debt ends up double or more of the original value, which is $100. Now, this is a lot of work to do by hand, especially if you don't know when you're going to be hitting this value. For the sake of efficiency, and you'll be able to utilize calculators when you're tested on this, and if you aren't, please let people have mercy on you, because this is something that professionals will use calculators for. I think you'll see that on the state
Well, he is, and I
assessment too.
see that you're going to use one, but let's have Nathan do it at the same time.
Great job.
So let's
do
have
that.
Nathan do it first. He'll give you his answer, and then you can verify.
So
Then I'll
Nathan,
triple check here.
For each value, you're going to multiply it by 1.06. And we'll see how many times you do that until we get at or beyond 200, double our original amount, all right? So
Okay.
go ahead, and we're going to do 106 times 1.06. And then tell me what you get.
I got 112.36.
112 and 36 cents after year 2. Great. Let's take that amount, 112 and 36 cents, and multiply that by 1.06. And let me know what you get.
119.1016.
Right, and so for the sake of dollar amounts, we really only need the first 2 decimal places. So we'll be able to represent that as 119.10, or $119.10. We're on a roll here. Let's take that amount, $119.10, and you can leave those decimal places if you have them still up on your calculator. That's great. You can keep multiplying by 1.06, or if you want to focus just on dollar amounts, you can look at just those first 2 decimal values. So let's do that. Let's keep it simple. 119.10 times 1.06.
Okay. I got 126 and 126.246, which would be 126.25.
Awesome. All right, we're 4 years in We have not yet doubled, but we can start to see the progress. Let's go to year 5. Go ahead and multiply 126 and 25 cents times 1.06. And let us know what you got.
I got 133.825, which would be 133.83.
All right, let's go with that. We're on a roll here. Let's keep going. We have a routine, and you tell me when it's time to stop. All right, let's go to year 6.
Okay.
And let us know what you got.
141.86.
141.86. Year 7. Go for it.
Okay.
My heart goes out to anybody doing this by hand right now. Let us know what you get,
Okay.
because we're getting there. You're doing great. I feel like we're still going to be in the 100s. So 141.86 times 1.06.
I got 150.37.
150.3. We're halfway there. Excellent. Year 8. 150.37 times 1.06. Let us know what you get.
Okay. 159.39.
159.39. Great.
So Nathan, before you keep going, do you have a guess as to the number of years it will take to do this? Because you're getting pretty close. Do you have a guess right now?
I'll say about somewhere between 9 and 11.
So
Something
you're
between
thinking
9
9,
and
10, or 11, right?
Yeah.
All right, keep going.
Let's see where we go. We're at year 9. Let's see what happens. 159.39 times 1.06. Let us know what you get.
I got 168.95.
168 and 95 cents. We are in year 10. 168.95 times 1.06.
And Devin, I would say leave it the way you've got. After 10 years, go over under your 106 and just
Yeah.
put years 11 and 12 if you need them.
Just right over to the side
Right.
here. All right, what did you get, Nathan?
I got 179.1.
179.1 you said, so in 10 cents?
Yeah.
Okay.
Yeah.
Year 11. This is at the high end of what you had predicted it was going to be. So let's try this now. 179 and 10 cents times 1.06 for that 6%. And let us know what you get.
189.85.
189.85. Nathan, I feel like we're going to get real close. It might be this next one, or it might be the one after that. And I'm basing that just off the fact that we're getting close to going up by $10 each time we do one of these now. So let's see where we go. It's year 12. Let's add 6% and do 189.85 times 1.06, and tell me what you get.
Okay. 201.24.
201.24. Nathan, do we need to keep going here?
I think yes.
if we were asked to find how many years it takes to double the original amount, and our original amount was $100, by year 12, we're past that double amount. So we have our answer here. It would take, at 6% a year, 12 years. If you don't pay any of this debt off on this junky $100 car that has probably been in the garbage dump now for at least 5 years at this point, after 12 years. But we've now spent 12 years ignoring this debt, and now it's double what we originally paid. Now, that could be true even if this debt was $1,000, $10,000, $100,000. After 12 years at 6%, it's going to be double what the original amount was. So Nathan, you chugged through it, nicely done. I hope that helps with some clarity in regards to the interest element.
There you go, Nathan. Nicely done, and it did take 12 years, and if you want to just make sure that it does, you can try yourself $1,000, go through that process again. It doesn't take too long now that you've got the hang of it, and see that it really doesn't matter what the amount is that you start with. Anyway, for that phone call today, Nathan, you are the first person to receive yourself the holiday lights at Calm right there. So congratulations. Hopefully you and your family have an opportunity to go enjoy that this holiday season. We also had an opportunity to go out to Maple School. Let's check that out in your class. Well, today we are at Maple School, home of the Mustangs, and we've got some 6th and 7th grade students ready to work with dominoes. So you've all had some experience with dominoes before, correct? Yes. We're not going to play dominoes like you probably remember, though. All right, so we're going to do something a little different. Can anybody tell me the difference between a fraction and a mixed number?
Fraction and mixed number? I believe like mixed numbers, they have a...
You want to write it out if it makes it easier?
Yeah, so a fraction is just that, and then I think that's a mixed number.
There you go. Right. Okay. So is everybody familiar with the difference between a fraction and a mixed number? Excellent. So, Gwen, correct? You and I are going to go first. All right? So what I'd like you to do is flip over any domino you like. If it is a double, like if it's 3 on top and 3 on the bottom, it's no good. Okay? So flip over any one you want. And put the larger number on top. Okay? Now what I want you to do is I want you to write that as a fraction. So mine would be 1/0. Now if you had to turn that into a mixed number, do you know what you would need to do? Go ahead and do that if you know, because if you had 5/2, what would that be as a mixed number? So how many times does 2 go into 5?
2.
2 times, so you would have 2 whole. And how many are left?
1.
Good. So 5/2 becomes 2.5. What is 1 divided by 0?
0.
0, right? So mine equals 0, yours equals 2.5. Who won? The bigger number wins. So who won? You. So you get both dominoes. All right? So you now are leading 2-0. Do you get the idea? So what you're going to do is you're going to, so you two will play together, you two together, and then Gwen and I. You're each going to flip over a domino. You're going to write it down as a fraction, improper fraction, right? Make sure the larger number's on top. If it is a number that is the same, you can't use that one. Just choose another one, all right? Turn it into a mixed number. Whoever has the larger mixed number takes both dominoes. Are you ready? Go. All right, so you won the first round. Let's go again. All right, so I've got, so you can't use that one, so just, we'll get rid of it, select another one. So I've got 5/1 equals 5. You have 5/4, so what would you need to do there?
1 can go into 3 times.
So 4 goes into 5, 1 time. There you go. So you have 1 1/4. I have 5. Who won?
You.
I did. All right, so there we go. All right, you ready to go again? All right. Oh, you got a lot of doubles. Try another one. All right, so I have 4 over 2, which is equal to 2. You have 3 over. There you go. So you've got 1.5, I've got 2. Close game on that one, wasn't it? All right, so since you're out of dominoes, I'm going to let you select one of these and I'll take the other one. Is that a double? Okay. So you have 2 over 1. Oh, I have a double. I'm out. You win. What would you have had? So if you need to write it down, 2 over 1, what does that become? 2. There you go. And I'm disqualified because they're the same. How are you girls doing?
Yeah. So 6 over 6 equals like 10.
It's 1, right? So it's just going to be 1. Because usually if you get the doubles, they're automatically going to be 1.
So it's a tie? Oh, so yeah.
There you go. So it's just another way that you girls can see that if you have improper fractions and you need to turn them into mixed numbers, this is an easy way to kind of practice it. And you can just make a little competition out of it, like, oh, I'll take the dominoes and stuff like that, right? So it's something a little different. You're like, I don't have a complete set of dominoes to play dominoes like you normally would. You can practice a math skill like that. And there we go, another little activity for the students at Maple School. And we had a great time at Maple School. Once again, thank you to the staff and students out there. We do have phone tutors available until 5:30. And in case you missed it at the beginning of the program, anyone that phones in and we do one of your math problems today, tomorrow, or all the way through December 8th, you'll receive a pass to bring your entire family, a carload, to Holiday Lights at Com. In studio, we have Alyssa, a 6th grade student from Castle Elementary, working on decimals and fractions. And we're going to continue that right now, all right? Head on over to the board, young lady. So, Alyssa, I will have you write down any fraction you like. Go ahead and write it up on the board.
What fraction do you have in mind?
4/5.
4/5.
15.
Oh, you know what? Did that freeze up here? Let me see. 4/5. Okay. So let's go ahead and write down 4/5. Give it a shot. I'll get that for you. 4/5. Okay? All right, 4/5.
All right. So, Devin, I would like you to come up with a decimal.
Are you sure?
Not I want you to come up with a decimal.
Okay.
We're going to be working with Alyssa, so we're going to compare
All right.
the fraction and the decimal and see if it's greater than, less than, or equal to her 4/5.
I'm going to go ahead and I'm going to keep it straightforward. I'm going to live in just the 10th place. So I'm going to go ahead and just give you this decimal here.
So Alyssa, before you start working with Devin, comparing these, because you want to take a guess, do you think 4/5 is less than 0.7, greater than 0.7, or equal to 0.7?
Maybe greater than or equal.
So, but you don't get
Just
2
plain
sisters, you
choice.
get 1.
Uh-oh.
You want to go with greater than?
Yeah.
All right, so let's go with greater than. So Alyssa is going to bet that 4/5 is bigger than 7/10. All right, so now go ahead and work through it. And if you're not sure what to do, Devin is right there to help you out.
Okay.
If you were going to compare these or see which one was greater, how would you start off? What would you begin with?
By probably either making the decimal a fraction or making the fraction a decimal.
Yeah, so the idea is you want to get them both in the same form so that you can make a direct comparison. So would you prefer turning 4/5 into a decimal or turning 7/10 into a fraction?
Turning 4/5 into a decimal.
Okay, so I'll go ahead and take care of this for you. I'm going to use, well, you know what, let me think about it this way. I think there's something to be said about the way that we said this decimal. How would you say this value?
I don't know.
So if you were to say this, like if you had to tell somebody what this was over the phone, what would you say to them? What is this?
0.7.
You said 0.7. Is there another way using place value to say this value? So this is very helpful, and I think especially when we're talking about comparisons. We refer to this place value immediately after the decimal as the tenths place. And that is actually very helpful because when we say the decimal version with this version, we're actually saying the fraction version of this, the value of this fraction. So how would I write 7/10 as a fraction?
Put the 7 as the numerator,
Right?
and the 10 as the denominator.
So what we just did right here is we converted 7/10 to a fraction very easily because we were able to use place value. And by the way, you could do that with this one, which would be hundredths. The same way over here, this would be thousandths. It just keeps going. It just makes it easier to convert. Now, these are both fractions. Can we compare them yet?
Probably.
How would you say? How would you be able to compare them if you say probably? If we're going to be able to say that one is bigger than the other, for example, if I have 5 apples and I have 7 grapes, I can't compare unless I say what I have more of. So I would have to compare them to something similar about them, fruit. When it comes to comparing fractions, I need to be able to make sure I have the same denominator for both of these. Now, is there a way perhaps to write 4/5 as a fraction that has the same denominator as 7/10?
Maybe by dividing.
Well, there's nothing I can really divide both 4 and 5 by that is a whole number. But how would I get from 5 to 10 using, let's say, multiplication?
Divide 5 by 2.
Well, I would multiply by 2, right. So if I can multiply 5 by 2 and get to 10, I can do the same thing up here with 4. So when I multiply 4 by 2, what do I end up with as my numerator?
8.
8. So 4/5 is equivalent to 8/10. Now, which is greater, 8/10 or 7/10?
8/10.
8/10. So if 8/10 is greater than 7/10, that means 4/5 is greater than 7/10, which means that 4/5 is greater than 0.7. So we'll just tie that off with that symbol we saw in the math in the news, the greater than symbol. And it's not going to let me draw it. But
Maybe
we
Alyssa
know-
can draw it up there. Are you
Give it a
able
shot.
to
Let's see if we're
put
able to
that
now.
greater than symbol up there?
Are you able to draw that there?
No.
Oh, maybe not. So we'll go ahead and fix that in
We
a
know
second.
it.
But anyway,
know.
Alyssa, some great work, and you did guess correctly. 4/5 was bigger than 7/10. And for your great work so far today, you've got yourself a meal courtesy of our friends at the Broken Yolk Cafe. So congratulations on that. All right, Devin, you're going to head over to the other board. Or you know what? You can just, let's go to the other
Yeah.
board since that one might have a little
know.
something going on with it. An 8th grade student from St. Francis was having a couple of problems that they were working on for homework. There are 2 problems over there. You're only going to have time to do 1. So let's go with the exponent that you've got right there, 16 and -3/2. And go ahead and evaluate that for our St. Francis student.
So I know that there are 5th, 6th, 7th grade students looking at this exponent and are having heart palpitations right now. Oh my gosh, there are so many things going on with this exponent. It's negative. It's a fraction. There is a numerator that is not 1 there. And so there are a lot of things to take into consideration when evaluating this. 16 is actually the easiest part to cope with. So it's important to recognize exactly what it is that all of these elements represent. So whenever we have this negative symbol in the exponent, that represents a reciprocal. So, for example, if I had 3 to the negative second power, this would essentially be 1 over 3 to the second power, or 1/9. So we'll keep that in mind. Anytime you have a value in the denominator here, that is going to represent the root of that value. So when we have a 2 here, we're talking about the square root of a value. So for example, if I had 25 to the half power, that would be the square root of 25, or 5. Now we have our numerator here. This is a straightforward exponent. So whatever we use for our root, we're going to bring it to that power. So we have a few things in play here. We're taking our original 16, and we have to bring it to the square root of 16. That's our first part here. Then we're going to cube it to the third power. And after all that, we're going to find the reciprocal of that. So we can start off with the square root of 16. Pretty straightforward. What number times itself equals 16? 4. So from here, we're looking at 1 over 4 to the third power. So now we're looking at this part, 4 to the third power. 4 times 4 times 4. So 16 times 4, 64. Which means all of this is 1/64. So 16 to the negative 3 halves power is 1/64. You do those little bits, you get there.
There you go. Nicely done. Thank you for that nice quick work. And hopefully that helps out Jack, the 8th grade student at St. Francis. And for giving us that problem to work on, Jack's also got a pass to go to the holiday lights at COM. We do have phone tutors available until 5:30. Phone numbers at the bottom of your screen periodically throughout the program. We'll be back with more right after this.
This week, Lab TV travels to the Armed Forces Institute of Regenerative Medicine's Wake Forest facility. Working with the U.S. Army, scientists there are doing some amazing research, and they're using ordinary inkjet printers.
I work in the area of bioprinting, which is the process of taking a normal desktop inkjet printer and you load the cartridges with cells instead of ink. And just using the normal method, just printing out a sheet of paper, you can print out a human tissue instead of ink.
With this new technology, doctors will be able to print skin cells on soldiers and other people with burns.
The Army is interested because burns can account for 10 to 30% of all casualties on the battlefield. The technology that we're developing isn't just going to be for the Army. We're hoping that eventually we'll be able to extend it to firefighters or policemen or other people who put themselves in the line of fire.
When people get burns, it's serious. That's because burns damage our body's most important line of defense, our skin.
Skin is incredibly important. It's the largest organ in your body, and it does things like retains water, it retains heat or gives off heat, and it helps provide a very important barrier against infection. So losing a large amount of skin in a burn can cause severe problems.
Burn patients might heal a lot faster if their wounds could be covered with new skin cells. But it's not as easy as it sounds.
A wound from a burn, it's not going to be flat. It's going to have a bunch of jagged areas. And in those jagged areas where the wound is deeper, you need to put a different cell type. So the cell type in the skin that's on the top is not the same that's going to be on the bottom.
They'll need to fill in the wound with 2 types of skin cells, fibroblasts and keratinocytes.
Fibroblasts are what make up the deep layer of the skin, and those help to produce the matrix that helps keep the skin held together. Keratinocytes are the cells that make up the top layer of skin.
The scientists can take healthy cells from the patient and then grow them in an incubator. Once they have enough, they load them into inkjet cartridges that have been cleaned and sterilized.
So this is how the skin printer will actually work. This is a patient bed. The print head is going to be mounted in the middle on these tracks, which will allow it to move across the body.
A camera scans the patient's burn and uses a laser to create a 3D map of the wound. Then the computer tells the printer where to start printing and what kind of cells to use.
So this is a normal inkjet printer that we've taken apart, modified for cell printing. We just load the cells right where the ink goes instead of ink. Now here is a regular inkjet cartridge. Now when the printer wants to drop a drop of ink, it simply sends a signal to one of these resistors, which heats up this copper wire, and that causes a bubble to form in the ink, which drops out a drop. That drop is roughly the same size as this cell, and that's how we can get single cell precision.
So the bioprinter drops each type of cell precisely where it needs to go. The wound gets filled in, and then those cells will become new skin.
I've always been interested in science. In middle school and high school, I was able to look at chemistry, look at physics, look at biology, earth science, all these different things, so you can find out what interests you and pursue that path.
And then you can do some amazing things, like turning an everyday printer into a machine that saves lives. To find out more about skin, burns, and bioprinting, check out labtvonline.org.
All right, as a reminder, we do have phone tutors available until 5:30. Anybody that phones in will receive a pass to Holiday Lights at COM. And right now we're going to go back to the phones. And Bo, how are you this afternoon?
Good. How about you?
I'm wonderful myself, thank you. You're in 7th grade, correct, at Rio Bravo?
Yeah.
All right, as soon as you're ready, go ahead and read the problem off, and Devin will be glad to help you out.
How's it going, Bo? Go ahead and tell us the math problem we're working on today.
It's X, and then the alligator, and -3. There's a line underneath it. Yeah.
Could you go ahead and repeat that problem again? I think it was a little different than what we were talking about earlier.
It was. Tell him the one that you told him I was in.
I think it was 5 is less than
Yeah,
R.
5 is less than R.
Great.
Was that the problem?
And then I think we had to graph this inequality, if that's correct.
Does that sound
So-
familiar, Bo?
So
Okay.
we're going to go ahead and work that. I think we lost Bo, but we still have the problem that he called in with. So we're going to go ahead and work this out. And we were asked to graph this inequality. Now, there's a few things to keep in mind. Generally, when we work with problems, as far as inequalities, we usually start with a variable. You might say like x is greater than 2 or y is less than 5. And here in this situation, it's the reverse. So if we're going to work with this in a standard format so that we can make sense of what it is we're working with, then I'm actually going to go ahead and reverse this. Now, when I reverse an inequality, I have to reverse all of the elements of it. I can't simply flip the variable and the value. So when I do so, when we say 5 is less than r, what we're also really saying is that whatever the value of r is has to be greater than 5. And if you think about it, that makes sense. If 5 is less than r, then r has to be greater than 5. Whatever r is, if it's greater than 5, that means 5 is less than whatever r is. Now, if we're going to graph this inequality, we're going to do so on a number line. And the great thing is, when we're graphing inequalities, we don't have to do too much. We can simply start off with the value that's given here, which is 5. So, 0 might be this way, 10 might be over here, and they'll continue forever in both directions. Now, when we're graphing, we also want to consider whether or not r could be 5. If that's so, we're going to see a sign, a symbol underneath our inequality symbol. It would be a bar, a line under it, which would equate that to greater than or equal to, but we don't have that here. So the first thing we want to consider is that whenever we have our dot here, this is going to have to be open because r cannot be 5. R cannot be 5 because 5 is not greater than 5. It's equal to 5. And so we wouldn't include 5 as part of the entire set of possible values that R could be. But anything greater than 5 could be R. So in that regards, we're going to shade in the line of all the values greater than 5 that would continue on forever. Now, you might, if you have pencil and paper, this might be just a matter of shading a thicker line on the number line. But you also want to make sure that you include that arrow, because we're literally including every single value in existence that is greater than 5 as part of what R could be. So if we're graphing 5 is less than R, what we're really graphing is R greater than 5. And so any value greater than 5 could be R. But we know 5 can't be, because 5 is not greater than 5, it is equal to. Now, if it was, if we had a bar under this here, if our initial problem was 5 is less than or equal to R, then yes, absolutely, we would shade that in, we would color it in to include 5 as the value. However, it's not the case, and we will remove that to be precise with our original problem. So 5 less than R would be graphed the same exact way as R is greater than 5.
All right, nicely done. Thanks for that. And Bo, even though we did lose that phone call, you've also got yourself some holiday lights at COM. So hopefully you and your family have an opportunity to go enjoy those lights. All right, one final thing. Alyssa, come on up here. And we're going to have you work on this a little bit, all right? So with these straws, they're cut into different pieces. And what number does that say?
508.
508, okay? Now, here's what you need to do. You can only move 2 straws, all right? So like this would be 1 straw, and any other straw that you can move would be counted as 1, all right? You can move 2 straws, and you want to try to make a number larger than 508, all right? So explain what you might think about doing, what 2 straws you think you might want to move, and because you have to get bigger than 508.
Oh.
All right. And they have to look like numbers still, right? And they have to be the same size as these, okay?
Okay.
So what are you thinking of right now? Before you even move anything, what's going through your mind?
Like 900.
So you want to do what?
900 maybe.
Okay, so you want to get up, you want to get higher than 500, right?
Yeah.
Okay.
Like that.
Okay. Now that's by moving 1.
Yeah.
So you did very good. You did it by moving 1. But if you have to move 2,
Can I move that to the here?
go ahead, do that. There you go. So now what number do you have?
980.
980. And is 980 larger than 508?
Yeah.
Indeed it is, all right? So put it back again to where it was. Good. So you've got 508, and you did exactly what I wanted you to do. You moved 2 straws, and you made a number larger than 508. Can you make a number that would be in the thousands now, instead of just a 3-digit number? Do you think you could get the number that is into the thousands?
By moving 2 straws.
Only moving 2 straws. That's going to be a tough one, isn't it?
Yeah.
All right. But show us again what you did the first time. Whoop, there you go. So you had the 900, and you moved that. There you go. So you did satisfy that right there. Did you learn a little something today?
Yeah.
Did you have fun?
Yes.
Excellent. And that's all we want. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District. with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.